There are 7 base quantities in our course. I'm doing question number 1. This one. I'm doing question number 1, SI base quantities. There are 7 SI base quantities, and everyone remember it: mass, time, temperature, length, current. The last two are not required, mole and candela. So we can leave it. So what you people suggest that if I remember the 7 quantities, what should be the answer? Joule is not an SI unit. Okay, one suggestion comes C. C, Kelvin, kg and Kelvin, both are SI. You people have to contribute your answers also. What is the ratio 1 micrometer upon 1 GM, gigameter? Such questions should be solved by a logic which I told you people in the class, that unit should be the same. C, C, C. But Usman, why so many C's? Just one answer is sufficient. C is right. The first answer is C. What is the ratio 1 micrometer is in 1 gigameter? Achha. Question number 2, we people are suggesting answer is D. So let's discuss that. 1 micrometer will be equal to 10 power minus 6 meter upon giga means 10 power say, but anyways, we can I have simplified it. You people can help me. Meter will cancel, and 10 power minus 6 minus 9. This is the working. Question number 2, answer is D. I have shown the working. You people have done it there in the paper, but you people can check it again. You can ask any query. There is no problem if the answer is wrong. The main thing is that you learn and you get it back. Now, this is these type of questions, like 3 is their favorite question. It means actually they give you strange formulas, and some of them you haven't seen before. He says, which formula could be correct for the speed of ocean wave in terms of density of seawater? The acceleration of free fall, the depth h of ocean, and the wavelength is there. Now the question is asking for speed. Now, what should I do? I should simplify all of them, and I should see which one of them is a speed. How I identify speed? Speed is meter per second. So let's see option A. If I simplify under root G into lambda, the unit for G is ms minus 2 into meter, and it is m square s minus 2. It is ms minus 1 whole square. Root and square cancels out ms minus 1. Luckily, our first answer is matching. But for practice, I want you people to check B. For practice, G upon H. It will be ms minus 2 upon m. Meter cancel. It will be s minus 2 s minus 1. It is not matching. Then rho gh. kg m minus 4. Kg won't cancel out, and in presence of kg, it won't be equal to speed. Just for practice, look D, G upon rho. G upon rho is again not possible because density contain, because density contain kg, and kg doesn't suit us. So for practice, I have done all of them, and I have concluded that answer is A. I have the whole working here on screen. And what I always tell, that you people should always try to do full working, so that you can get the right answer. Doesn't matter, it takes time initially, but you can do it in full working so that you can get the idea how to tackle it. 5 energies are listed: 5 kilojoule, 5 millijoule. These type of questions, I have told you a hint, always come in SI unit. So 5 kilojoule means 5 into 10 to the power 3 joule, 5 into 10 to the power minus 3 joule, 5 into 10 to the power 6 joule, 5 into 10 to the power minus 9 joule. Now the power is there. Okay, one answer suggestion is C. Now you have to arrange them. You people have to arrange them from smallest to increasing magnitude. Smallest. Who would be the smallest? Nanojoule. Okay, majority people have a consensus over C. I have done the working. Answer is C. Question number 5. Which of the following correctly expresses the volt in terms of SI unit? Volt. Remember, volt is a unit of voltage. Voltage is equal to work upon charge. Work upon charge means joule per coulomb. Joule per coulomb. And joule is Newton meter. Coulomb is ampere into second. Newton is kg ms minus 2 into meter into a minus 1 s minus 1. Majority people have reached D. I have shown the working also, and you people can compare the working and the answer. Hmm. Okay, define the following. These definitions are simple. Vectors are those quantities which have a direction and a magnitude. Scalars are those quantities which do not have a direction, only magnitude. How we define SI base quantities? Can anyone give the definition of number 3? What are SI base quantities? The quantities. What are SI base quantities? The quantities which laid the foundation of physics. They are the fundamental quantities. They are the fundamental quantities, and they are called SI base quantities. So physical link, good relation. Acha, number 4, what are derived quantities? What should be the definition of derived quantities? The quantities obtained from the base quantities are called derived quantities. What should be the definition? Base unit should be same. Achha, you people have now on part V. Dimension is actually a link between a derived unit and a base unit. It's actually a link. For example, distance and displacement are dimensionally the same. They have the same unit. Moment and work are dimensionally the same. So I think some people forgot the definition of dimension. So dimension is a link between Dimension is a link between base quantities. Dimension is a link between base quantities and derived quantities. So this is called dimension. Two of the SI base quantities and their units are mass, kg, and length and meter. I have given examples, Zara. I had given examples. I give them again. That dimension, for example, I take the O-level example for the time being. For example, moment is Newton meter and work is also Newton meter. Work is also Newton meter. Work is also Newton meter. These are called base units. I am not converting them to base because the derived is the same, so I can get them back. So it's a link between the physical quantity and the base quantity. Actually, the concept of dimension should be well understood by a sentence that two quantities are physically the same, physically the different. Let's see how it works. Doesn't matter, it's the first test. So let's discuss this concept actually. We will say that work and moment have the same unit. Work and moment have the same unit, but they are physically different. This is a concept to remember. Dimension means the quantities which are unit-wise same, but concept-wise different. Moment and work are not same. Moment and work are not the same, but their unit is the same. Two of the SI base quantities and their units are mass, kg, and length. Name three other SI base quantities and their units. So you people can answer it easily. Temperature, Kelvin. Quantity is temperature, for example, temperature, and the unit is Kelvin. There are 7 base quantities. Time and second, okay. Quantity is time, unit is second. Third one, what should be the third one? No, do not go for luminous intensity. The last two should ignore them. Current and ampere is fine. They're not wrong, but better to stay in the first 5. The pressure P, rho, the pressure P due to a liquid of density rho is related to the depth H by the expression. Use this expression to determine the derived unit of pressure. Doesn't matter. I'm saying it's not wrong. Mass can't be there. Mass is already given by the examiner. Mass is given by the examiner. Examiner has mentioned mass and length. So you can't give them, but candela is fine. Candela is not wrong. Okay, now he says base unit, find the base unit for this. P is equal to rho GH. So rho is kg meter cube into ms minus 2 into meter. So look at this working, a short working. Showing some steps is fine. I have shown 3 steps. So if you have shown, suppose 2 steps, is it still it's fine. No, I have 5-6 minutes. I want to continue for 5 to 10 minutes more. Then I will finish the class because I have a chance of doing one more question because it's only 30 to 28 minutes here. So we have time, so we can try one question more. No, just one question. Just only for 5 to 10 minutes. You have to bear there because we have done some work today, so we can try an easy question, not a difficult. Show that the SI base units of power are kg m square s minus 3. Please note down the year, June 14, 1. Show that the SI base units of power are this. Power is equal to work upon time. So power is equal to joule per second, Newton meter per second. So when you simplify Newton, it's kg ms minus 2 into meter upon second. And when you simplify it further, kg m square s minus 2 upon s. When you move this s up, it will become s minus 3. Look at the working, simple working, only one question and then we are terminating the class. Please look at this working. The rate of flow of thermal energy in a material is given by this. A is the cross-sectional area, which is meter square. T is the temperature difference, which should be in Kelvin. X is the thickness, which is in meter. C is a constant, and he says the unit of C. If you want to find the unit of C, First, make C the subject. I have made C the subject. Examiner says rate of flow of thermal energy. So it should be joule per second, which we already have determined in our upper working. Joule per second is actually power. Kg m square s minus 3. So start putting all of them. Kg, I'm putting this for Q upon T, m square s minus 3. So this is the unit. These are the units. So I have to simplify them. On the top, there is a meter square and there is a meter. So it will become meter cube s minus 3 upon meter square into k. Kg m square, sorry, kg m cube s minus 3 into m minus 2 and k minus 1. Kg, it will be 3 minus 2, 1, s minus 3 and k minus 1. So this is actually a relation for the unit for C. So we are stopping here and we will inshallah continue in our next class. Allah Hafiz.